In this video, we're going to look at slightly more complicated uses of logs in equations. And so, for starters, let me just draw your attention down to these 2 points. And so, the one point is that the powers in a log equation can go to the front and vice versa. So, what I mean by that is if I had something like that, one of the log laws is that the power can go to the front, and so that would be 7 log x. And obviously it works vice versa, that if I had 7 log x, I could take that 7 and make it a power. The second one is if there's a minus between logs, it means that you can divide it as a single log. And so if I had log 10 minus log 2, then I can write that as log 10 divided by 2, which is just log 5. Likewise, if I was plussing 2 logs, I can times them as a single log. And so it would be log 3 plus log 2 is just log 3 times 2, which is log 6. So these are 2 of the fundamental laws of logs. Looking at it in an equation, check what it looks like. 2 log base 3x plus log base 3x plus 1 equals 2. And so for starters, if you've got a random constant term that's not a log, you want to change it into a log. You want to change it into a log with the same base. And so what's happening in the background, if I forced it to be a log base 3, because everything else is a log base 3, then that 2 is like a microscopic little 2 inside there, which you never see. And that's how you get the other number. So 3 squared is 9. And so obviously it would just look like this. Here's another example. If I had lots of log 4s and at some point I had the number 3, then it would be, I want log 4s microscopically, just for your own reference, that would be a little 3 there. So then the other number would be 4 to the power of 3 is 64. And so if you needed to, you could convert the number 3 into a log base 4 to the 64. And so that's what I've done here to start. I wanted to get everything to be log base 3s. And so 2 represents log base 3, 9. And so that's the one magical use of constant terms. The other rule that we spoke about here is this power, the number in the front, becomes the power. And so there it is. The reason I do that is so I can do the second law that I spoke about, where there's a positive, you're going to times the 2 terms together. So you don't want stuff stuck in the front of a log when you get to that step. And so it's just x squared times x plus 1. And once I've done that, because I've got log base 3 of this equals log base 3 of that, then the this will equal the that. And I can bring that across, and then I won't do it for the purpose of this video, but you can go on to solve this cubic equation from there. And so that is hopefully a nice introduction to slightly more complicated log law equations. The last thing just to comment on from this video is that the numbers in the 2 log base and the other number can't be negative, and so you can't get minus 3, 5 or log base 5 minus 3. So just look out for that as restrictions. You can't have negatives there. I hope that you found this introduction to log laws helpful. If you did, please like this video, subscribe to our channel, and share it with your friends. Thanks.